Welcome to AI in 8 minutes or less, your daily AI update.
Today, we're diving into a really fascinating hardware puzzle, one that could actually save you $1,000 or more.
So here's the big question. You've got the NVIDIA Thor with a massive 128 gigs of RAM. Then you've got the DJI Spark, also with 128 gigs of RAM, but it costs way more. On paper, this seems like a no-brainer, right? Just get the cheaper Thor. But is there more to the story? Well, we're going to find out. And just for fun, we're throwing the brand new Apple Mac Mini M4 Pro into the mix to really stir things up.
Okay, now take a look at these specs. The RAM and price are interesting for sure, but the real key here, it's that memory bandwidth column. See how all three, the Thor, the Spark, and even the Mac, are sitting at an identical 273 gigabytes per second? This is huge. Memory bandwidth is often the biggest bottleneck for AI, so by making it the same for everyone, we get to see what these different architectures can really do.
So before we start running any crazy AI models, let's get a baseline. And we're going to start with something people usually forget about: how much power these machines are drawing just sitting there, doing nothing. And wow, right out of the gate, the difference is just massive. The Mac Mini is barely sipping power at only 8 watts. It's incredibly efficient. Then you have the Thor at 31 watts, and the big boy Spark is the thirstiest of them all at 44 watts. Now just keep these numbers in the back of your mind, because they're the first chapter in a story about efficiency and design. All right, let's get to the fun part. Test number 1. We're firing up the new Mistral 3 model. Now, this is what's called a sparse model, so let's quickly talk about what that actually means. So think of it like this. A sparse model doesn't use its whole brain at once. It's smart. It only activates the specific parts it needs to answer your question. This can make it way more efficient, and it leads to some pretty interesting performance results. So, let's see how our contenders handle it. And boom, our first surprise of the day. When it comes to token generation, that's basically how fast the AI can type out its answer. The little Apple Mac Mini actually takes the win. It's pumping out 39 tokens per second. The Spark and Thor are right there, but hey, a win is a win. Round 1 goes to the Mac. But hold on. That's just how fast the answer comes out. What about how fast the machine understands the question you asked it in the first place? That's called prompt processing. And this is where the story takes a sharp turn.
And just look at that. This is where the NVIDIA hardware just wakes up and decides to dominate. The Spark is absolutely screaming, processing over 2,400 tokens a second. This is raw, brute force computation, where those specialized tensor and CUDA cores inside the NVIDIA chips just show what they were built for. The Mac gets left in the dust here.
Okay, that was the warm-up. Time to really push these machines. For our next test, we're bringing out the big guns, the massive 70 billion parameter Llama 3.3 model. This is what's called a dense model.
Now, a dense model is the exact opposite of a sparse one. It's not picking and choosing which parts of its brain to use. No, it's using every single parameter every single time. It's a brute force approach, and it is incredibly tough on the hardware.
And you can see this monster model brings all 3 machines to a crawl. The token speeds have absolutely plummeted. But wait a minute, look who's on top again. The Mac Mini, even with half the RAM of the others, is still managing to edge them out in token generation speed. That really speaks to how efficient Apple's unified memory architecture is. But just like before, when we flip over to prompt processing, it's a completely different ballgame. The NVIDIA Spark is still the undisputed king of computation, nearly 10 times faster than the Mac. And this really matters if you're working with long conversations or feeding the AI a huge document to analyze. So we've seen what they can do, but now let's get to the why. Why are their performance profiles so completely different? To figure that out, we got to look at how much power they're using under load and what's actually under the hood. And this table tells a fascinating story. That incredible speed from the Spark, well, it doesn't come for free. Look at it jump to over 150 watts. That's almost double what the Mac Mini is using to run the same heavy model. All that power comes at a serious energy cost. The Thor, meanwhile, sits right in the middle. More efficient than the Spark, but still way more power hungry than the Mac. So here's the why behind those numbers. Both NVIDIA machines are built on the same awesome Blackwell architecture. But the Spark just has more stuff. More tensor cores, more CUDA cores. That's where its raw speed comes from. On top of that, its CPU is built on a more advanced process, which basically means it's better and faster at feeding data to its super powerful GPU.
So, let's wrap this all up. After putting these machines through their paces, which one should you actually get?
Well, like with most things, it really depends on what you need it to do.
Looking at our two NVIDIA contenders, it's a very clear trade-off. The Thor is all about efficiency and what we call deterministic performance. That just means it's incredibly consistent and predictable. It does the same thing, the same way, every single time, which is critical for things like self-driving cars.
And when you add the Mac to the equation, it carves out its own niche perfectly. It's the champion of getting the final answer out quickly, and it does it with unbelievably low power consumption. It's just a fantastic all-around performer.
So let's finally answer that first question. Is the cheaper Thor the better buy? Well, if you're building a robot or an in-car AI system where power and predictability are king, then yes, absolutely. But if you're running a server for lots of users who need instant responses, the Spark's raw speed is what you need. And the Mac Mini? It's turned out to be a powerhouse efficiency machine, perfect for a developer's desk.
And that really brings us to the final takeaway. Specs on a sheet, like the amount of RAM, only tell you a tiny part of the story. The real question you have to ask is what matters most for your project? Is it the raw, explosive speed of the Spark, the balanced, predictable efficiency of the Thor, or the surprisingly zippy and power-saving performance of the Mac? Think about it.